We have seen functions. So it is something which does a particular task, a piece of code. And also we have seen the return value and the arguments in the return value we have seen. The code we know how it looks. If you want, you can review the previous presentation, how the function looks. Now what we are going to do is we are going to look at the slides to see if there are any concepts we are missing. As you might have seen, going to the slides or the concepts a little later after the code. In case if you want to do the other way, what you can do is you can come back to it, look at the concept and then look at the code. So the idea is that suppose I'm teaching you elephant. First I'm showing you a bigger picture using code, what the elephant is. And then I'm showing you what are the different parts of an elephant. For example, elephant has a trunk. It has 4 legs. Unfortunately, this picture is hardly looking like an elephant, but these are the 4 legs of the elephant. And then it has a tusk, which is the long teeth, and it has eyes. And this is the long nose of the elephant. And it has some ears somewhere here. So this is not the mouth, it is the teeth. It has a mouth as well to eat food and all. So this is the tail. So this is how I normally do things. You can do it in any order you want. You can go and review the training again and again. But we looked at the function code, which is the overall picture of the whole thing. Then we are getting into different details like so. Being said that, I'm coming back to the concepts of functions. So we have seen this delegation of work to experts. So let's focus on this particular point. The summation function we have seen, the function has the actual logic to calculate the sum of 2 numbers or concatenate 2 strings. We have seen that. And the caller is delegating the actual work to a function. The expert here is a function and the caller is the delegator. So the caller is delegating the work to a particular function. We have seen code reusability. What this means is that we can call that function many number of times with different arguments. We will get proper result based on the argument. When we passed 20, 30, we got 50. Or 30, 40, we got 70. Whatever value we were passing, we got the correct output based on the input. So we can call it any number of times. We have seen arguments passed into the function to values. You can have any number of arguments, including 0 number of arguments. Arguments can have default value, etc. We will see that hopefully in future. Return value, which is the output. So arguments are input. And return value is output. Now there are some other names or jargons used for functions. One is method. You may hear this particular name for a function, especially if the context is a class, which we will learn later. Normally the functions are called methods, but they are one and the same thing at the end of the day. Another less used name for a function is subroutine or just routine. I have seen this used in pretty olden documents from the 80s and 90s, but subroutine is also nothing but function. At the end of the day, functions are nothing but piece of code which we normally reuse with different arguments. That is the simple definition of function. So these are the couple of points we already discussed. Normally, always instructions are executed top to bottom. So we have seen that, top to bottom. CPC is one at a time. That is also something we have seen, one line at a time. But in the case of functions, we have seen the exception as well. It came down, then gone up, executed the functions, and then came back. So let's see that quickly in a block diagram. So the same thing we have seen. So we have a function here called fun1, and it has a couple of lines of code, and it takes an input and gives an output. And this is our main application, our main code. This is also having a couple of lines, and then what it does is it calls a function, pass an argument. And get the return value right here. So the CPU execution goes all the way like here, execute all these lines, and then execute all these lines and come back here and return the value and keep executing these lines. That's what happens when we call a function. Again, if we call the same function, it goes again just like that, execute again, probably with a different argument or same arguments, without argument, doesn't matter. It comes back, return here to the starting point of the function execution. So that always happens. So this is what we have seen in the code execution of function. You can have any number of functions like this. You can have fun2, and you can call fun2 from the rest of the program or from somewhere else. We'll see more than one function in the next program we are going to see before we wind up the topic of function. So this is what I wanted to discuss on the block diagram, just how the execution of function works. We have seen this just now, and example we have seen in the Visual Studio Code. Now, one of the things I would like to show you is the debugging part. Most of the things we have already seen. F9, we have seen the breakpoint, the red dot which came right here, is where the program freezes. The program freezes the execution until one of the following keys are pressed. So this is when someone hits a breakpoint. When it reaches the breakpoint line, what happens is the program freezes. The program freezes the execution until one of the following keys are pressed. Either continue. Continue means that continue the execution until the next breakpoint is hit. This is F10. F10 is step over the current line expression. So don't worry about all this jargons which I'm using here. It's not exactly same, but we don't have to be too rigorous here. So this is approximately translating to a line. Step over the current line. So which means that just execute next line, which is pointing to that yellow arrow was pointing to. Just execute that particular line. That is F10. We have seen that a lot. Now F11, this is something we are going to see right now. F11 is nothing but if you see a function call, go inside that function. And this is exactly opposite to F11. If you're inside a function, execute that function completely and get out. So we have not seen these two items. I will show you just now. It's easier to show you than explain because it's all just like the elephant which I was telling you. Once you see it, you will understand rather than getting too much into the theory of it. Now let's quickly see this part of the elephant as well as all these items in the exact same program we were looking at. So this is the program we were looking at. So let me simplify this program. So I'm going to remove this part of the execution and this part of the code as well. So I'm making it very simple. So we are having a function here, adding two numbers, and 30 and 40 is the argument we are passing. Plain and simple, straightforward. So probably what I'll do is I'll just Control X and put it here so that it'll make a little more sense. So this is before the execution of function. This is after the execution of the function. So I'm going to remove this breakpoint for the time being. So first what we are going to do is we are going to put a breakpoint here, and I'm going to start F5, start debugging. F5 is also continue and start debugging is all same. Now if I do continue or F5, you can press F5. I'm going to press this button F5. It will execute till the next breakpoint. In this case, I don't have any breakpoint coming up. So it is going to completely execute the program. So the program got completely executed and printed everything, and the program ended. So this prompt right here means that the program is ended. Program finished execution. Now, if I put another breakpoint here, so we are discussing F5, the use of F5. Now, the first breakpoint has hit. Now I have another breakpoint in line number 11. So again, I'm going to press F5 here, press this button. So it hit this breakpoint right here. It is not printed after function. So after function is not printed, and this prompt has not come. So the program is still executing, and it's waiting to execute this particular line because the yellow arrow is pointing right here. Again, I'm pressing F5. It has completely executed. Now let's see the working of F10. Again, I'm starting debugging. F5. Now I got this breakpoint hit. No surprise. I'm going to do F10. So in the case of F10, it executes each line at a time. Now it has executed this line. Now it's waiting to execute line number 8. I'm going to press F10 again. It has executed that line, waiting to execute line number 9. It is waiting for any key to be pressed. Again, F10 and F10, final F10. So it has finished. That was the line number 11. Line number 11 was the final line of the program. So it has finished it and finished the program. Now, again, I'm going to start the execution. It is waiting for line number 6 to be executed, which is kind of the first line of the program, F10. Now, line number 8 has a function call. So we have seen functions. Now I want to debug that function. I want to go inside this function. If I press F10, it'll execute this and return the result. It'll completely execute this particular line. That's not what I want. What I want is I want to go inside the function. So that is where F11 comes into the picture. Step into the function. So that is what we are going to do. So F11, as you can see, it moved the execution to this particular line number 3 with all the arguments. If you look, all the arguments are here. The function context is visible. Alternatively, you can put a breakpoint here as well if you want, which is something I have done before. You can try that if you want. You can put a breakpoint, but sometimes F11 also helps. Now you can do regular step over to execute that line, to execute inside the function. Now if you do F10, it'll finish the function and come back here because there is no more line inside the function. Now it can execute just like the way it is. So F11 is nothing but step into the function. So that is F11. Now shift F11 or step out. Let's see that. So for that, I'm going to restart. So this is restart. Control Shift F5. If you want, you can do that. So I'm going to restart it here. So it has started the execution again. The whole program has started again. So that is restart. Now again, F10, F11, it came here. Now if I don't want to execute this program line by line further, or this particular function line by line, I can finish the execution of this particular function and come back. That is where F11 comes. So it'll execute line number 3 and 4, but it will not debug it. It'll just finish the execution and come back. So let's do that. As you can see, it finished the execution and came back. But this line is not finished, just a function is finished. As you can see, the yellow arrow is still pointing to line number 8, which means that this part is yet to be done. As you can see, the locals are not changed. So it is showing something very interesting. My sum equal to 70. So my sum, the function, the return value of the function is 70. This was not there before. If you look, it is yet to create this variable. So this part is yet to execute. All it has done is it has finished the execution of this function and returned the value here. Now what we are going to do is we are going to press F10 so that we got the value here. And the new result has created. So this part is also executed. And regular F10 or F5, whatever is your preference, you can go for it. So step into the function is F11 and step out is Shift F11. There is one more thing I want to discuss regarding debugging right here, which is something called call stack or stack trace. Both are one and the same thing. In the Linux world, normally they call it stack trace. In Windows world, it is normally called call stack. I'm not going to spend too much time on it. If you are not able to understand, it is also fine. So I'm going to stop debugging here. For stop debugging, it is Shift F5. So the execution has stopped. I'm going to remove all the breakpoint. I'm going to give a breakpoint here inside the function and start debugging again. So if you look here, so this is the main execution point, the main function or the main script. And then from the script, we have called a function right here. If we have called another function from this function, it'll come on top of it. So this call stack is a debugging technique which shows the call order of functions. And when we click on it, we can go to that particular point of the call. For example, if we click, you can see there is a green arrow has come up. It means that from this point, line number 8, there is a call happened to mysum, which is a function here. Don't worry if you're not able to understand it. We will see it a lot in future and you will get used to it. So a lot of these things, you need to get a feel of it rather than understand everything. A working feel of a lot of concepts. Some of the things you have to revisit and re-watch again. Some of the things you have to play with the Visual Studio Code and the debugger and program, changing the program yourself and see how it goes. Some of the things you may have to come back and ask me questions. As I mentioned earlier, I am not teaching everything in the order. It is impossible to teach everything in the exact order. So some of the things I'll discuss in the beginning and explain it later. So you may have to watch the training more than once. Don't forget that. So call stack we will see later. It is not a very easy concept at the moment. And good thing is that call stack is not something we really need at this point in time as well. I was just explaining it for the sake of completion. All we need is going to be watch, locals, and F11, F10, Shift F11. In fact, we will be only using watch, locals, and F10 and breakpoint, which is F9. So nothing to worry here.